Welcome all into this new show and tell we're doing today. Last time we had an awesome presentation from Pavel. These recordings are also online. Some of them are chopped up so you can see them per topic that he discussed. This time, Bas will be presenting the work that we're doing on Pixi Build. I would also like to mention we just released a new version of Pixi, which is using a lot of great bug fixes and a new version of UV. So please check that out if you didn't already. And yeah, I would like to give the word to Bas. He will share a screen with the presentation and hope you like it.
Let me unmute. There we go. So, hi everyone, welcome again. So, I wanted to talk a little bit about Pixi Build and the status of that. We've been working on it for a little bit. So I will go over some of the goals, some of the design decisions that we made, and the status as of where we are now. So what we want to achieve is that Pixi should be able to support building packages from source, because currently we only use binary packages. And we have a couple of use cases, but the most important ones are the ability to build a Pixi project directly into a Conda archive. So in CI, you can just call Pixi build and it will produce a Conda archive for you that you can then upload to a channel. Without having to manually maintain a recipe.yaml or a meta.yaml, which is currently sort of the workflow. And we want to be able to have multiple source dependencies in a workspace and use them together. That would look something like this. So we have a myc library that has a pixi.toml, and we have a mypython library that references the C library. And in the pixi.toml, you can have a dependency directly on the source of the C library, and it will compile the Conda package for you, and you'll be able to use it in your workspace. We added, but I'll go over that a little bit more. We added that you have a build section now that also has some of the dependencies. I'll get to that more. And you can not just depend on different paths, but you can also depend on Git repositories directly, or URLs that will have archives or files. And you can also, our goal is to also be able to directly depend on a feedstock or on a recipe that you can then use in your project. And it will be built when needed. So these are some of the goals. So we want to be able to use source packages as Conda dependencies. We want to enable support for workspaces, so having multiple projects in a single repository. We want to do Pixi build and Pixi publish so that you can generate these artifacts and push them to a channel. We don't want it to be limited to just Pixi projects because there are multiple ways to build Conda packages. We want to support multiple build systems so that you can build your Python project, but also your C++ project, or Rust or Julia or whatever. So yeah, that's also the way we want to support multiple languages, and we want this to be future-proof as possible, so that if you have a very old project, it will still be able to build with very new versions of Pixi. So one of the things we had to do was change the solver code. So the solver now always gets all the metadata up front, but when we have source packages, we also need to first build or get the metadata of the source package so that we can solve for the source dependencies as well. And at installation time, we also have to make sure that we actually build the source package into a Conda package so that you can actually install that. We split the work into a front end and a back end, very much inspired by the Python Py project, where you have an executable that's responsible for the actual creation of the metadata or the package. And we have a front end that's integrated into Pixi that spawns this backend because it can be a separate executable, and then invokes the commands in there to do the things it needs to. And people are free to implement their own backends. So if you have like very specialized backends to generate this metadata or package, then you can implement your own. So the build backend is really like responsible to provide a build interface to Pixi, and we will probably allow this to be in your pixi.toml. You can specify which build backend to use, very similar to a PyProject.toml. So in the little example at the bottom, you see that there is a dependency on pixi conda build, which is a backend that we didn't build, but we could build. But for some of the other manifests that we want to support, so not just pixi.toml, but also recipe.yaml or a method.yaml, we have a predefined backend that is used that we also provides this interface. The frontend and the backend communicate through JSON RPC. So we spawn the backend as the executable, we run it, and we expect that we can send JSON RPC messages to it and that we can get JSON RPC messages back. So it's a communication protocol between these two executables. The schema for this we will also build, and the people can look at it and change and implement their own backends. And we are looking at how to make this as future-proof as possible so that you can have a very old backend because you're using a very old project from source, for instance, and it will still be able to communicate with a very new front end, or the other way around. You have an old backend or old front end that interacts with a new backend. And we want to do this through the means of capabilities. So there's one sort of handshake request through with the JSON RPC, then and the front end basically specifies these are sort of the capabilities that I have that you can depend on, and the backend will then communicate back with these are the capabilities that I have, and once they know from each other what they can do, they can sort of adapt their communication to make that to do the things that they need to do. So if we change an API, we can always add a new API, and then the front end or backend can depend on those newer APIs. We took a lot of inspiration from the language server protocol, which has a similar thing. And we were really inspired to do it this way because of the setup tools thing that happened, was it 2 weeks ago, where setup tools increased their major version, which broke a lot of older packages in the installation. We want to make sure that that doesn't happen here. So the current status is that we want to get, we're basically taking the quickest route to something that works, so that you can depend on a source package from your pixi.toml and that the whole workflow works. But we are still not implementing everything, so there's still lots of missing pieces, and we still also have a lot of open questions. But we do want to adhere to sort of high-level design to make sure that we don't go a completely different direction later. So what we already did was we created a bunch of new crates that you may have seen in pull requests. So pixi spec is already merged in main, and it allows you to write dependency specification not just on conda packages but also on source packages. So with match spec you can't really describe source packages, but with pixi spec you can. And pixi spec can then be converted to a match spec if it's a binary representation. We built the pixi build frontend in a PR still. It's not merged at all. And that provides sort of the API to pixi to be able to invoke a backend and communicate with that backend. It's also a separate tool, so you can also invoke pixi build frontend. I'll show you that a little later. So that you don't have to go through pixi to test all of these functionalities. At the moment, we also do not yet support downloading a build frontend, sorry, a build backend, but you have to specify that manually at the moment. So that's one of those missing features that we'll add later. And we can already sort of extract metadata from a source package with a backend. Then there's pixi build, which is a separate repository that contains an example implementation for a Python package. And that repository contains pixi build Python, which is based on Rattler build. So it generates a recipe from a pyproject.toml or a pixi.toml, and then invokes Rattler build to build a package or get the metadata from the package. but we take a lot of shortcuts. So we know, so this is a Python package, so we assume that Python and pip need to be installed and those sort of things, and we'll make that better in the future. So I already mentioned this, but we still have many open questions, like how to deal with variants, because that's going to be an interesting one, because a recipe you usually build for different variants, and how can we determine which variant it should use at runtime or when we solve it. How do we adapt pixi manifest for native projects? So what will building for C++ packages requires more steps than the Python Python project. So what will the pixi manifest look like to support different backends? And finally, this is a big one as well, like how can we support like editable Python installs? So editable Python installs are a package that only works on your machine because it references specific files on your machine. And it's quite similar to incremental build. So how can we build a package not in isolation, but reuse the previous information from previous builds? And also we want, when you publish a package, you want a release build, but when you debug a package, you might want a debug build in case of C++. So how do we deal with that? So that's still some unanswered questions. And there are more. So let me show you a little bit of a demo with what we can do at this point. I'll have to reshare. Whoops. That's here. Stop streaming. Go to this one, I think. Yeah. So I can invoke the pixi build frontend tool directly. And like I said, I currently have to override the backend, or the build tool as we call it. But I'm currently in a feedstock called the Boltons feedstock, and I specify this tool will currently get the metadata and then report that back to the CLI, but it will do so by invoking the backend already. And currently the backend tool that I use is Conda build directly. This will also change in the future. This will take a while because Conda build is relatively slow, and we'll probably be able to optimize that in the future. So while this is running, let's go to another thing. So I can show you, this is a backend that we built, pixi build Python, to create Python packages. And it's an executable that I can invoke. And if I invoke it without any arguments, then it will give me a JSON RPC server on the std out and std in. So I can pass it some stuff and it will reply with some JSON RPC. So this is just to show you that it communicates over JSON RPC. And then I also have this example. So this is just the example that we have in Pixi, which is the Flask Hello World PyProject example. And I can invoke sort of the same tool here, but instead of the Conda build backend, I use the pixi build Python backend. And this spawned the pixi build Python executable, communicated over RPC, JSON RPC, invoked Rattler build to render the recipe, and it gave me this metadata back in the front end, which I print. So this will be the input for the solve, which will be sort of the next step to run this. And what's important is that this also has to take run export dependencies into account. So it has to download a bunch of packages to determine do these packages also have run exports, and if so, they also need to be included in the metadata that we have here. And this is all we need to be able to solve for this package at runtime. This should also be done now. So this is again from the feedstock, and you can see that it also gave me the same metadata, but this was extracted from a feedstock instead of from a pixi tom or PyProject. So it looks like not a lot, but there's a lot of machinery going on in the background, and we have a lot of moving pieces, but we just need to sort of fit them together now to get to an integrated result in Pixi. So I'll go back to the Show&Tell presentation. So in conclusion, this was like a very quick intro into Pixi build. We still need to do a lot of stuff. we're developing all of this in the open, so there are some open PRs that you can check out. We will also share this presentation later, so you can actually click the links. But these are issues in or PRs in pixi, and this is a separate repository that's under prefix dev and then pixi build. And we do very much welcome any feedback on Discord or otherwise, and also immediately now, because we also have a number of questions for you, which are these. So first, let me sort of open all of this up for questions that you might have, and then if you can want to answer one of these questions, then feel free.
Is it planned that there is any integration into Conda Forge, so you could use your pixi toml file to create Conda Forge packages?
So not directly, but what we do want to be able is that you can quickly generate a recipe based on this. So that you have a backend that will just generate a recipe, or we can do it through existing backends. Not entirely sure yet.
So you could create a meta YML file from the pixi toml?
Yeah, that would be
okay.
that would be
Yeah,
okay.
that's sufficient.
Yeah.
Maybe another question to your third point. I'm not sure if I understand it entirely. So would you need to create a source dependency from my package instead of doing a PyPy editable install, or what is like what would replace mean in this case?
So maybe Julian can explain this a little bit with what he had to do in RebaSim.
Sure. So at least for if you have a bigger project, one situation that you often have is that you have things which depend on each other but are developed by the same team. Like for example, you could have multiple Python projects. Project A depends on project B, and you can develop them at the same time quite conveniently because there are editable installs. But different languages don't necessarily have this concept. You might, like for example, on one of the earlier slides, we had one example. We had a C dependency, which a C library, which was a dependency of Python, of a Python package. Like for example, one of the use cases that we would like to cover is that you would have kind of an editable dependency on a C project or on anything which can be handled by pixi. But it could also be Python. You wouldn't have to use Python editable installs anymore. Could directly depend on a pixi toml, on a pixi project.
So it basically has the same functionality as a PyPy editable install, just for other languages.
That's for every language, yeah, including Python.
Yeah, if it works the same, I don't see an issue in not using it.
So addressing the first question, speaking of PyPy, so let's assume I want to create a Python library, and for some people in my company, they're not yet on the Conda train. They still expect my library to be available in a PyPy repo. So is this something pixi build can also support, or would I need another tool which basically transform my Conda package into a PyPy package?
Yeah, let me answer that. Like in my head, like the ultimate goal for that Python thing is exactly that, so that you would have one Py project YAML file, that we would have a flag or something in the Py project that interpret my PyPI dependencies array as Conda dependencies. So then you can install it as a Conda and Python, and if the mapping is correct, then that should work, right? And then you can just use pixi build to create a Conda file, and you could create like whatever task you have for Python. I don't know if you would make a build task for it, we could also do that, but already existing machinery can make that into a wheel, right? So you can just use the build front end or hatchling or whatever and then you could create one. Like the cool thing for that is that you would create a wheel and the conda file from the same project source, which is currently not possible because either there are PyPI dependencies or there are conda dependencies that PyPI doesn't know about. So this does require that all the dependencies would be available on conda because you cannot have PyPI dependencies in conda either. But if that's the case, then you should be able to create a wheel from both from the same source file. That's my ultimate goal for this. So to cover that use case exactly.
And for that use case, the source of truth would be PyPI, right? Like the PyPI dependencies would be the source of truth, and we infer the conda dependencies from that.
Yes, if my hope is that that will work if you have a good mapping, and so there's a couple of caveats there, but I think it'll be very useful because it's very hard to do or impossible currently. So and I think there's a lot of use cases in the Python world where you would want to create both the wheel and the conda package.
Yeah, thanks. I think like using two tools for creating different things would actually be no problem. But as you said, I think the crucial part is that the dependencies are managed by a single source of truth and we don't have to duplicate them.
Yeah, agreed.
Yeah, that's just error prone and also, it's just not as nice of a user experience, I think.
Also behind, like for the user, it would be one tool because the PyPI publishing tool could be a pixi dependency and then a pixi task.
Great, thanks.
So thanks everyone. It's very interesting. My use case, I guess Bas and Ruben team, they are familiar with it. It's basically a bit probably far-fetched because I would like basically to replace the Colcon plus the VC tool plus Colcon workflow that is typically used in robotics project with something like based on pixi build. And this is clearly related to the incremental compilation. Also, and because at the moment it seems to me that you can depend on folders, but Pixi is not going to create those folders you depend on. So you need something external like a VCS tool to create those folders, if I got it correctly. I don't know if you have any idea, given that you are familiar with that workflow. Yes, but then if you depend on a Git dependency, I think you cannot modify the Git dependency, or you can. So that it's a bit because sometimes you just want the pragmatic Git dependency because it doesn't exist in Fonda. It doesn't exist in Vine, and that's great. But let's say my use case typically for people building from sources that so if they find a bug, typically what happens is we have three teams all working on libraries from different teams. So they are different repo. You cannot do a mono repo. It will be a bit complicated to couple them, but still is something that they want to be able to modify because it's not a stable dependency. It's something that their colleague on the other room wrote. So he has a lot of problems. If there are problems, they want to call him and sort it out. So they want to be able to modify the source. And that's why people use VC2 plus Colcon or CMake super builds or whatever. So Kind of, yes. That's the dream, let's say. That's the dream. Clearly, it's also conflicts a bit with pixi, because as soon as you locally modify a Git repository, you're not reproducible unless you commit in that repo, you push, and pixi somehow gets the new checkout. So it's kind of going a bit far from the idea of
So
idea
you-
of reproducible environment.
So you actually want a path dependency that can be generated by Pixi itself, or fetched by Pixi
It will
itself.
be cool. It will be cool, because otherwise, if you don't do that, imagine that I have 10 directory. I need to do something before Pixi is invoked, because I think Pixi wants already the directory there as soon as you do Pixi ls. So I cannot have it as a Pixi task to create a directory, and you can do it. You have a VC tool, you do a VC import from a YAML, but the strange thing is that you cannot do it with Pixi, because Pixi expected it already there whenever you do a Pixi command, if I'm not wrong.
But the VC tool also gets the code from a repository somewhere, right?
Yes, it gets just, you specify the YAML with all the Git repositories.
But then couldn't you also put that directly into the pixi tool?
But then at the moment, you cannot then modify the directory, if I'm not wrong.
And so this is workspaces is also something you use in Rust regularly. So what I would do then is clone that repository, and then in my pixi toml refer to that path, and then I would fork the Git repository or whatever. And then once I'm sort of happy and I want to share it with people, I would just add the fork to the pixi.toml, and then it works out of the box. Because you still also need to change or share the modifications with your colleagues.
Yes. But you create this repo manually.
Yeah.
You clone that repo manually. When you start having 10 repositories and you want people in the team to do that automatically, because because you want them to have the setup ready if they need to modify something.
Mm. Yeah, so
Because they are not experts. They are not you or me or probably most of the people in this chat. Well, what typically we do is that we prepare that call on workspaces or CMake super builds, and they just type the commands, even with pixi. Now we have to build with pixi, and if something goes wrong, you tell them, okay, modify this file, reinstall everything, and they can do in-source modification of C++ project from their setup. If you had to tell them, okay, at this point, remove this dependency from binary, clone the repository at the same version you are having, then add it to your pixi toml, they couldn't do that. They don't have the skills.
So I think I can provide a bit of insight on that. Because I worked in my previous job in Julia, and to my understanding, at least my colleague did it all the time, one common workflow is that if you have a certain dependency, for example, in your case, a Git dependency, it's quite normal to go to this well-known path where this Git repository is checked out and then modify it directly. And I have no idea if there are annoying edge cases, but apparently that is a normal thing to do in the Julia community. So we could at least investigate that. The second one, which I would be interested in, you mentioned, Silvio, you have multiple repositories, you have a quite complicated dependency tree. Which languages are involved though?
Mostly C++.
But no Python, for example?
Typically, if there is Python, it's bindings that are built through CMake.
And you have
Because Python tends to be like leaf dependencies, so they are not part of the tree.
Understand.
And then they are also, quite easy to install in that editable mode, and so people are familiar with that, and it's not the complicated part for us. The complicated part for us is being able for people to reproducible install a bunch of C++ projects from source, either because binaries are not available or because they need to be able to modify them as soon as possible if something goes wrong.
But
And
these
the switch from sorry?
These C++ projects, do they depend on Conda dependencies?
Yes.
Yeah. Nice.
Yes. Typically, you have a huge chunk of dependencies that are provided by Conda, in binary form that are mostly what, if you were using APT, will be provided by Ubuntu, like stable OpenCV. Then a bunch of dependencies that are written in C++ that can also be available, that we made also available on Conda, but people in the lab don't want to use the binary because then if they find a bug, and that happens frequently because they are research libraries that are developed by researchers, so they are far from perfect. They want to be able to modify them soon because they are working on the demo on the robot. They don't want at that point, okay, I need to uninstall this package and all the packages it depends on and reinstall them all from source. Because sometimes the library that you want to modify, it's not a leaf dependency, something in the middle of your tree. And so if you want to switch from binary to source, it will be too complicated because you will need to uninstall that binary and all the packages on which it depends and reinstall all of them in source.
I think
And that can
we
be
know,
okay.
I think we know exactly what you were describing because that's precisely how the tool worked we built at our previous company. There you could set like this dependency is a source dependency, then it would look in the tree like, oh, which dependencies are above that between like in the tree between the main dependency and that dependency. It installs all of that from source and builds that for you with the dependencies you currently have. So I think we know exactly what use case you have. We just have to think about how could we support that with the pixi build setup. Because that's also probably what Diogo, that's also in this call, would need to switch to pixi completely. He's nodding yes. I know his microphone is not working. So that's very good feedback.
Yes, just to explain it, that will be quite an advanced feature. I will be even happy to specify everything already from source, but you can edit it. That is something easier because it's not switching from binary to source. But I wanted to explain why you cannot just say, yes, depends on the binary, and then when you need it, switch it from source because that is too complicated. I can probably do it, and it takes me 1 hour. Most of the PhD students cannot do that. They're not they're not able to do that. They don't have the skills. They don't know all the dependencies, what they need to uninstall.
No, that makes sense. Thank you.
And then they come to you. And they say, help me, Sylvia.
And that's the biggest problem. That's that they come to you and me, and then I cannot do anything else. But all this work is really exciting, by the way. Thanks a lot.
Thanks. Is there any more questions from you guys? Then if not, or if about something else, please feel free to leave them in the chat or in any of the other channels. We'll gladly help you. And as Bas just switched, thanks all for listening. I think Bas did a great presentation, and I hope you will enjoy the future features that are coming into pixi as we speak. And see you at the next show and tell.